Hey guys, this is a video to go with section 10.3 in your textbook, and today in 10.3 we're talking about combinations. So let's read that definition and compare it to something that we already know. A combination is a selection or a grouping or an arrangement of objects in which the order is not important. Now permutation is what we did in 10.2, and permutation is similar. It's an arrangement of objects, but the order is very important. So what I have here is two situations that are really similar. One is going to be a permutation, one is going to be a combination, and we're going to kind of compare and contrast combination versus permutation. Okay, so this is something that we would have done already, something that you already know how to do. So this is an example of a permutation. Find number of ways to choose a president and a vice president from 5 students in student council, and the students' names are Bob, Ann, Ken, Liz, and Ron. I just picked some 3-letter names so it's easier to write. So the idea here is that order is important because choosing Bob for president and Ann for vice president is not the same thing as choosing Ann for president and Bob for vice president, right? So like the ordering is important here. These are 2 different outcomes or 2 separate outcomes, okay? So what I have listed is all 20 outcomes. And what I did to get those is I basically just kind of went through systematically. I said, okay, I'm going to pair Bob with Ann and then switch them. Then I'm going to pair Bob with Ken, and then switch them. And then pair Bob with Liz, and then switch them. And then Bob with Ron, and switch them. So those are all the combinations where you have just Bob is one of the people. Then you go down the line, you say, okay, well, let's pair Ann with Ken, and then switch them. And Ann with Liz, and then switch them. And Ann with Ron, and then switch them. And then you go down and say, okay, well, let's start pairing Ken with people. Well, he's already been paired with Ann and Bob, so we just need to go to the right. Let's pair Ken with Liz, and then we'll switch them. Let's pair Ken with Ron, and then let's switch them. Okay, then we moved on to Ron to Liz. Now again, Liz has already been paired with these people, so we go, let's pair Liz with Ron, and then let's switch them. So you can see that these are all the 20 combinations, or excuse me, all the 20 permutations of this scenario. Okay, and order again is really important here. So if we wanted to, do this without counting all of them up or systematically like listing them all, we know we could do that by using this formula that we had yesterday. What we want is a permutation or an arrangement where the order matters of 5 people but chosen 2 at a time. Okay, so this was our formula. When you want a permutation and you have this many things to choose from and you want to take them this many things at a time, this is the formula that we use for that. Okay, so in this case we would say, okay, well, we have 5 people total to choose from, and then we want to choose 2 of them at a time, right? A president and a vice president. So what we're going to do is we're going to have 5 minus 2 factorial, right? 2 is the amount of people. So that in this scenario we have a 5 and a 2, right? And a 5 and a 2. Okay. So this is 5 factorial over 3 factorial. Okay, and if we write that out, we got 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And we'll cancel, 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 and that equals 20 options, right? And there's all 20, okay? Now, when they ask for how many ways to do this, you don't always have to list them, right? You can just use the formula and figure out, well, there's going to be 20 here, because that's a permutation. The order is important. Another way to think about this is if you think about, the fundamental counting principle. If I want to choose 2 people, I'm going to choose a president, and then I'm going to choose a vice president. That's 2 different events, right? So for event 1, choosing a president, I have 5 people to choose from. Okay, for event 2, which is choosing a vice president, I have 4 people to choose from because I already chose a president and now there's only 4 people to choose from. So that's going to be 20. Now mathematically, what we want to be able to do is, how do we write this? How do we say to somebody, okay, here's what you're going to do. You're going to take the number of people that there are, and then you're going to count down 1, you're going to multiply it by that number. This is the way you do that. This is the mathematical formula for getting that 5 times 4. Okay, so there's 20 options there. Okay, now that's a review. We've already done that before. We haven't listed it out like this, but you can kind of see how that's going to work. Okay, now this is a combination. This is a little bit different. Very similar scenario. Find the number Find the number of ways to choose a 2-person committee from 5 students in student council. So the same 5 students, Bob, Ken, Ann, Liz, and Ron, But now the order doesn't matter, right? So if I choose Bob and Ann for a committee, I don't want to also choose Ann and Bob for a committee because it's a committee. The order isn't important. It's just the same two people. So we're not talking about the order being important. Bob and Ann and Bob are not two different groupings in this scenario. They are over here, but here order is not important. So if we take out all the doubles, right, we kind of eliminate, okay, well I have Bob and Ann, but I'm going to eliminate that one. I have Bob and Ken, but Ken and Bob is the same on this side, right? So take this guy, eliminate all the duplicates, you get this listing. Okay, there's only 10 of them. The question is, how would we come to that number if we didn't want to list it all out? Okay, so here's the deal. Basically, in the permutations assignment that we did, we had some scenarios where we had too many objects and we had to like divide them out. Or sorry, too many permutations and we had to divide some things out. Like when we had repeated objects or when we had circular permutations. We find the number of permutations that there are and then we're like, okay, now there's too many. Let's divide out the extras. Okay, that's kind of what we're going to do here. So in order to get all the permutations, you do 5 factorial over 3 factorial, right? That would be all the different permutations of this. But then you think to yourself, well, hold on. If I got 2 permutations, that's too many. So I need to divide it by how many ways there are to order 2 things. Okay? So how many different ways are there to order Bob and Ann? Well, if you're going to choose Bob or Ann, you have 2 choices, and then you choose the other one. So there's 2 times 1, or there's 2 factorial ways to order 2 people. So what you do over here is you say, okay, 5 factorial, 3 factorial is all the permutations. What I need to do is I need to make that less. So I divide it by however many ways there are to list 2 people, because then you eliminate all the doubles. That's kind of what we did here. Now, with bigger numbers, there's more ways. So like, let's say I had 3 people, right? How many different ways are there to order 3 people? Where there'll be 3 factorial ways to do that. So the idea is, when you set up your formula, notice that this part of the formula is just permutations, right? It's the same formula as the permutation formula. The extra piece is, okay, you have to divide out the duplicates because we don't want all the duplicates. So that's how you get rid of the duplicates. You take however many things are in your list, however many things you're choosing, or however many things you're taking at a time, and you do that factorial on the bottom. So this is actually a little bit out of order. Let's switch it so it makes sense and matches this. So 5 factorial, 3 factorial, that's the permutation part, right? But we also did the 2 factorial because we needed to divide the duplicates. So let's go ahead and finish this up and see what we get. And we should get 10, right? So 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. So all the 3's and 2's and 1's are going to cancel. And then we got a 2 times 1. Now this 1 doesn't really matter, right? Because 1 can cancel with anything, basically. But this 2 will cancel with a 2 that's in the 4. So this is 2 times 2. So let's actually go back and do that again, just so you can see what I'm doing. Okay, so this 4 I'm going to replace because 4 is equal to 2 times 2, right? And then I can cancel one of these 2's with one of the 2's that was in 4, which leaves me with just 5 times 2, which is 10. So there's 10 different ways for this to happen. So the whole idea of combinations and permutations, the difference, in combinations, order is not important. So to get the number of arrangements that you can have where order is not important, you take all the arrangements where order is important, and then you divide out the duplicates. And this little guy right here, r factorial, is how you divide out the duplicates. Because again, you're figuring out, well, if I'm picking 2 things at a time, how many ways are there to order those 2 things at a time? There's 2 factorial ways to do that. So that divides out those duplicates right there. Okay, next video we'll look at another example. We won't list out all the different options, and we'll kind of practice and compare and contrast. But that's the main difference. And again, notice the formulas are very, very similar. The only difference is in the combinations, you have that extra r factorial down at the bottom.